Hi, welcome here to the 8-bit area at Microchip Masters 2016. My name is Andreas Eyeland. I'm the Director of Marketing for AVR 8-bit products, and I want to show you a couple of the demos we're showing here today. First of all, we're doing something interesting here. We're showing you guys that an IoT end node doesn't have to be a Wi-Fi Bluetooth monster. You can do it really simple, you can do it really easy. Inside this box we have a 1K flash 14-pin micro and an AM radio, and we're using that to control the light here. So basically this is a $1 IoT end node. Really nice setup just for simple control in your house. Another demo I want to show you is the peripheral touch controller that's inside our latest devices. This is a simple capacitive touch user interface for buttons, sliders, or wheels. But some of the unique things we're doing here is our latest solution, available in the latest generation of products, also work even with water rejection. This is great for things like appliances, any surface you might want to wash, car doors. There's a whole host of applications, sports watches, where you need to be able to reject water and not have your application go bananas if it gets moisture, sweat, your pasta water boiling over. This is a really nice and stable solution for that. In this demo setup here, I have something we call the power debugger. Traditionally, you've only debugged code for code correctness to make sure your application runs as you want it to do. Now, after moving into more and more low power devices with more and more power optimization needed, being able to have a way to monitor what your device is doing from a power point of view is getting important. So in this demo here, I have our power debugger connected to a small board with an AVR micro on it. And the code in this application is just rolling through different operating modes. And you can see here on the output screen, live power measurements data. And if this is doing my power debugging and I suddenly see a spike I don't understand, I can actually go to this point in the graph, click it, and Studio 7 will take me to the point in the application code where my code was running before that spike. So it's a feedback loop for you to enable low power debug. And the beauty of this device is not only does it work with all the 8-bit AVRs, it also works with the PIC micros. So we also have a demo here at Masters where we're running the exact same setup on a PIC kit with the same output. A great debugging tool for everyone. This is a demo that shows the core independent peripherals on 8-bit AVR microcontrollers. In this setup, I'm using 2 timers, 2 lookup tables, and the event system to do ultrasound distance measurements. So when I'm making changes here, and you'll see the values change on this display, I'm not using any CPU cycles whatsoever to measure this distance. The only CPU cycles I'm using is to send the data to the display. This is a real good example showing that you don't necessarily need a lot of CPU resources to run an advanced application. If you have intelligent peripherals that cooperate, it really offloads the CPU and makes the total system more efficient. I hope you enjoyed the demos. If you want to learn more, please visit the URL underneath this video, and thanks for watching.